Hi, I'm Tony Northrup for TrainSignal, and in this lesson I'm going to teach you how to configure Internet Explorer, the web browser. There's more to it than you might think. This maps directly to Objective 2.5 for the Microsoft 70-687 certification exam. And in the official objectives, they list 5 different sub-objectives. Configure compatibility view, which lets Internet Explorer do a little bit better job in rendering websites that were designed for older versions of Internet Explorer. Configure security settings, which is really important because Internet Explorer by default is configured to be very secure, which is good, except that it's so secure that some older websites won't work properly. This is closely related to compatibility view because basically you would change the configuration settings to fix something that was designed for an earlier version of Internet Explorer. The third sub-objective is manage add-ons. Add-ons are little software apps that run within Internet Explorer and add some capabilities. So Flash is an add-on. Adobe Flash is a tool that adds interactive capabilities to websites, and it's probably the most popular of the add-ons. Add-ons are really important to understand though, because add-ons are also frequently exploited by malware companies. So they'll release all these toolbars that annoy you, or maybe when you're shopping they'll redirect your links so that either they get a few dollars of it or they'll send you to a different website. Anyway, there are lots of good add-ons and lots of bad add-ons, so you need to understand how to manage them. We'll also talk about how to configure WebSockets. WebSockets are this two-way communication technology that allows web pages to add real-time capabilities to web apps. Now, there's not actually anything to configure, but I will show you what they are so you have an understanding of them. And the final sub-objective is to configure Download Manager, and that's just the tool that downloads files for users. First, I'm going to show you how to configure compatibility view. So let's pull up our Windows 8 PC. Now, first in Windows 8, you have two versions of Internet Explorer. The first is this Windows 8 version of Internet Explorer. It's the kind of Metro-ized, full-screen interactive version, and you launch it from the start screen here. But that's not the version we're going to use for this. So I'll jump to the desktop here and launch Internet Explorer from the toolbar. This opens up the desktop version of Internet Explorer. So you'll notice it's not full screen like the Metro version. It is exactly the same as you'd experience in Windows 7 and earlier versions of Windows. Now, imagine a scenario. A user has just upgraded from Windows 7 to Windows 8, which includes a new version of Internet Explorer, i.e. 10, and suddenly a website isn't rendering properly. What would you do? Well, there's a couple of different ways to handle it. You can handle it on an individual basis by using Internet Explorer settings, or you can handle it for the whole company by using group policy. So let's start with fixing it for an individual person. The first thing you'll do is open up the website, and I'll use my own website just as a demo here. And this is pretty easy. You'll see this little broken page icon here. Right now it's grayed out, which means compatibility view is not on. That's the way it's going to work for almost every website on the internet, but not every website. Microsoft canvasses the internet and finds websites that render properly in older versions of Internet Explorer, but not the new version of Internet Explorer. And if it finds one of these websites that needs compatibility view by default, it puts it on a list. And Internet Explorer will download this list periodically, and if it visits a website that's on the list, it shows it in compatibility view by default. The end effect is that users can browse the web with a new version of IE, and for at least popular websites, they'll never notice any compatibility problems because Microsoft has already informed IE of the problem. But maybe it's an internet site and it's not rendering properly. You'll open it up and then you'll click this so that it goes from being gray to being filled in. You can see it's a darker shade of blue now. It's kind of a subtle difference. But now the page is being rendered in compatibility view. So what they're doing now is they're rendering it with the older version of IE's rendering engine. It's exactly as if it's running in an old version of IE. So when Microsoft went through and made all the improvements to how Internet Explorer renders pages to accommodate all the new HTML standards, that broke some old websites. Compatibility view will fix them. So now let's take a look at how to do that using group policy. I'll jump back to the start screen and launch gpedit.msc. That's the group policy editor. Now I am editing the local computer policy, as you can see here. However, this works exactly the same if you're editing group policy for every computer in an Active Directory domain. It's going to be in exactly the same place. So I'll look under Computer Configuration, Administrative Templates, Windows Components, and then Internet Explorer. And in here you'll see a variety of different options for configuring Internet Explorer. There are a lot of different tools you can use. Under Compatibility View, naturally, you'll find the options related to Compatibility View. And here's the setting that's going to be most important to you. Use policy list of Internet Explorer 7 sites. Now, you know we're on Internet Explorer 10 now, so why are we talking about Internet Explorer 7? Because that's where Microsoft made the big change to the rendering engine, is between versions 7 and 8. Versions 8, 9, and 10, you're probably not going to notice any difference. They do add some new capabilities, but there's probably nothing that's going to break older websites. But honestly, Internet Explorer 7 and earlier, they use these really funky renderings that, well, they weren't standard. And most of the internet kind of frowned on the way Internet Explorer rendered things. But a lot of web designers, well, they just kind of do what they need to do to get their website running. So they built their old websites around these kind of ad hoc standards that Microsoft made up for Internet Explorer 7, and they might not render properly. So that's part of the problem, and that's why it says use policy list of Internet Explorer 7 sites instead of, say, Compatibility View sites. Edit this policy, enable it, and then on the list of sites option, click Show. And here you'll enter in a list of values that the URL should match for compatibility. So if you want to always show the website intranet.contoso.com with Compatibility View, you would enter it here. You can also use wildcards such as *contoso.com to include all websites in the contoso.com domain. There are a couple other relevant policies here. Include updated website lists from Microsoft. Controls whether or not your browsers will download that list that I discussed from Microsoft and render those websites in Compatibility View. You can simply disable that if you want to block it. If you want to turn off the Compatibility View button so that users cannot manually render websites in compatibility mode, just enable this Turn Off Compatibility View button policy. And finally, if you don't want users to ever use Compatibility View, just enable the Turn Off Compatibility View policy. Now we're ready to move on to the next demonstration. In this next demo, we'll learn how to configure security settings to fix a website. So why is this even a problem? Why would you have to change security settings to fix a website? This goes back to the same issue with Compatibility View. In that Internet Explorer 7 and before, well, they didn't do things great. They didn't do things the way that the later versions of Internet Explorer do. One of the weaknesses that they had is they let websites do a whole bunch of stuff on the local computer, like store files and access files. And that was fine back in the innocent years of the web when websites just wanted to render stuff. But once hackers found out about this, they started putting code on websites that would hijack users' computers and steal information and install software. So Microsoft then had to kind of retrofit Internet Explorer with all these security controls that would prevent these websites from doing things. And as you can guess, that broke a bunch of websites, legitimate websites that weren't trying to do anything dangerous, but maybe they ran a particular add-on like the Microsoft ActiveX add-on that did something useful on the computer, but couldn't work with the security settings. So let's take a look at how to change those security settings so that you can allow those components to work properly when you need to. I will jump to the desktop here and open up the desktop version of Internet Explorer. Now I'll open up the settings here by clicking the gears icon and move down to Internet Options, same place it's always been. The Security tab here has all our relevant settings, and you'll notice 4 different zones here. Internet Zone is everything that's on the internet. By default, every website's in the Internet Zone, and you can see the default security level for this zone is medium high. Now, for the certification exam, it's going to be really important for you to understand these different levels. So let's take a look at these different levels. High means that Internet Explorer is running as restricted as it can. It minimizes your security risk, but honestly, most websites aren't going to run properly in high. For example, it disables cookies and other things that legitimate websites need to be able to just track what you're doing on the website, like follow your login and authentication information. So that's the reason that high isn't enabled by default. Even though most aspects of Windows are considered secure by default, this has the second to highest security, medium high by default. And medium high works with most websites. You'll notice that it prompts before downloading potentially unsafe content. This is kind of their approach to allow websites to work properly while keeping you as secure as possible. So when a website that's probably legitimate wants to do something on your computer, Internet Explorer will show a bar at the top, or it will just prompt you to confirm something. So it forces you to kind of make a choice. You should always read those prompts, don't just skip past them. But most of the time it's just a bar that appears at the top of the screen that if you don't know what you're doing, you might just ignore. So it requires you to actively opt in to things like installing new toolbars. And notice this last option here. Unsigned ActiveX controls will not be downloaded. ActiveX is kind of this really old thing that was like Flash but could do a lot on the computer. ActiveX could literally read your documents and have pretty unlimited access to your computer. As a result, malware companies released a lot of malicious ActiveX controls. Legitimate companies released useful ActiveX controls too. Now, the legit companies probably signed them. The malware companies probably didn't sign them with a legitimate certificate, and if they did, they could be easily blocked. Therefore, by default, the medium-high level blocks unsigned ActiveX controls. And this lowest level, you can choose medium. Still prompts you before downloading unsafe content, and ActiveX controls will not be downloaded. There are a bunch of more minor settings that medium configures, but I don't know of any reason you'd want to choose medium as your default for the internet zone, because medium high works just fine. Now you'll notice several other zones here. The local internet zone applies to all computers on your local internet, and that means literally your local area network. If you're a network guy, it would be anything on your local subnet, stuff that doesn't have to go through the router. By default, they get a little bit more privileges. As you can see here, it just says most content will be run without prompting you, and it's the same as the medium level without prompts. So websites can't do anything extra on your computer, but the stuff that they want to do, you don't have to respond to a prompt for it to work properly. You'll also notice this checkbox down here is no longer checked. Enable protected mode. Protected mode runs Internet Explorer in a separate process and just helps reduce security risks a little bit more. For the local internet, protected mode is not turned on by default, but it is for the internet. Now here's the zone that's going to be most important for you to understand for your work life, and that's trusted sites. A lot of the times companies will set up an internet website that needs to run some custom ActiveX control that does a whole bunch of stuff. It might not technically be on the local internet. Maybe it's a partner's website that you need to use. You'll go into the trusted sites zone here and add it to the sites list. We'll go through a little scenario in just a minute that will do that. The last zone here is restricted sites. These are for sites that you just know are bad. Now, I don't know why you'd want to visit websites that you already know are bad, but if your users are, and if you've had infections coming from a particular site, what you could do is go into the list here and add those dangerous sites to the list of restricted sites. And when users visited them, they might still be able to visit them, but anything that could introduce a security vulnerability will be eliminated. So they won't even be able to track cookies, much less install add-ons from the website. So they'll be able to visit, and most of the security problems would be restricted. So let's imagine a real-world scenario, and this is actually really common. Your organization partners with a company, we'll call them Fabricam.com, and Fabricam has an extranet website. Now, here's a term. Intranet means it's a website that's within your own organization for internal use. Extranet typically means it's a website you set up for partners, not necessarily consumers, but other businesses that want to interoperate with you. So you need to connect to this extranet website, and you go there in Internet Explorer with the default settings, and it doesn't work right because it needs to, say, configure an untrusted ActiveX add-on. Also a really common real-world scenario. Okay, so your boss tells you, look, I have a user that needs to go in and connect to Fabricam's extranet website. It's not working. Can you see if you can fix it? Here's what you do. You open up the Internet Options dialog, go to Security, click Trusted Sites, click the Sites list, and then add in the URL of the website. So this is a happy accident. Notice that this checkbox down here requires server verification. It requires that the website use HTTPS. Now, if the website supports HTTPS, if it has an SSL certificate installed, in other words, then you should go ahead and add that to the beginning of the URL. That will require users to visit the website using HTTPS. If the website does not have an SSL certificate installed, you can clear that checkbox and add the standard HTTP in there. Now that you've added the website, you would only need to add one or the other of these. You can click Close and OK. And when the user of this computer visits that website, Internet Explorer will treat it with medium security, which allows it to get away with more things and which doesn't prompt the user for so many different choices. Now, I want to go back a little bit and discuss the difference between HTTP and HTTPS. HTTP is not secure. So I'll just visit Microsoft.com here. And when you visit a website with HTTP, everything is sent in clear text. So if I were sniffing this network connection, like tapping a line kind of, I would literally see the words "for home" come across. Anybody could do that that has access to your network. Now, if you add that S in there, this becomes a secure connection. Everything in a secure connection is encrypted. Besides encryption, it does something important. It authenticates the server. It makes sure that the server has a valid certificate for the name that you typed in here, which in this case is www.microsoft.com. And that helps stop man-in-the-middle attacks. And a man-in-the-middle attack, another server might change your DNS server configuration so that you visit their server instead of the legitimate server. And this happens a lot with banking. You might be going to, say, your bank, say Bank of America, and they'll set up their server to impersonate Bank of America. And if you use HTTP to visit Bank of America, you'll never know. You'll put your credit card information in and they'll just steal it. But if you use HTTPS to visit Bank of America, you'll know, because Internet Explorer will come up with a warning and say, hey, the certificate doesn't match. You should be careful when visiting this website. So that's an aside, but that's the importance of HTTPS. Now, let's look at how to configure a trusted site using group policy settings. So here we are in the local group policy editor once again. And if you don't remember, Internet Explorer settings are hidden under Administrative Templates, Windows Components, Internet Explorer, and then we have all of our Internet Explorer settings. The Trusted Sites list is under Internet Control Panel. I know that's not easy to remember. Then one level down, you'll find the security page. Now there's a lot of settings here. It gets a little chaotic, but you'll want to look for Site to Zone Assignment List. This group policy configures which sites are in the trusted or not trusted list. So I will edit this and enable it, and then you can see this option, enter the zone assignments here. Now you'll want to remember to look at this description because they number the zones. They don't make it as easy as you might want. You can see that you can assign specific sites to any of the 4 zones, though for the most part, the only zones you ever assign are the intranet zone and the trusted site zone. And most of the time you'll just use the trusted site zone because either you trust the site or you don't, right? So I'll click show here and put in a URL. And then the value that corresponds to the trusted sites list, which here is 2. And click OK. Now, with that policy set, everybody in the organization would be able to visit extranet.fabricam.com and have it be trusted. So mission complete and your boss will be happy. Now, before we move on, I do want to open up Internet Explorer once again and take another minute to go through some more of the internet security options. You can see most of the time you're just going to use these different zones to control the level of access that websites get. For the exam, I want you to understand what happens when you click custom level here. You will see a ton of different very granular settings that you can go through and configure. And I'm not going to walk through them one by one, but I would like you to spend a couple of minutes and take a look at the variety of different settings here. Now, it's not likely that the exam is going to ask you specifically to be able to name permissions for components with manifests, because there are simply too many of these settings. And that is why Microsoft provides these different security levels. They basically summarize a group of settings that are consistent. One of the most important settings here is ActiveX controls and plugins. Now, ActiveX filtering helps to protect you from malicious ActiveX controls. You could disable that setting, and that would drastically reduce your security against malicious ActiveX controls. But then again, if you have a legit ActiveX control, it might just solve your problem. So take a few minutes and go through each of these settings. We'll move on to the next demonstration. Now let's talk about managing add-ons. Add-ons are these little apps that run within Internet Explorer, and they add more capabilities. A lot of times they're implemented as toolbars, but they could also add content within a particular web page. So let's imagine that a user has installed the infamous Yahoo toolbar. Nobody wants this Yahoo toolbar. You'll see it here. But sometimes it gets installed with other apps, and it's taking up real estate space on your screen, and it offers a search here, but why would you not just search up here? I don't know why anybody would want the Yahoo toolbar. I don't think anybody has ever intentionally installed it, but nonetheless it gets installed all the time when you give users the right to install add-ons. So imagine that your boss has done such a thing, and he calls you into his office and says, get this thing off my computer. Here's how you do it. You'll click the settings icon here and then click manage add-ons. Now here you'll see, oh yes, look at all these toolbars. For each one of these, you're going to click it and then click disable. Click it and then click disable. Then click close. Now we'll close Internet Explorer and start it back up again. There you go. No annoying add-ons. Now I'll show you one closely related tip. Sometimes you'll get add-ons installed that won't even allow Internet Explorer to open at all. Like you try to open it up and it just crashes, or it's got stuff appearing everywhere. It can be a real nightmare. From the start screen, just search for add-on and then switch to search these settings, and you'll see an option here, manage browser add-ons. This opens up the Internet Properties dialog without actually launching Internet Explorer. So if you're having a problem opening Internet Explorer, this is what you want to do. You want to open that up and then click the Manage Add-ons box here. And you can see that you get the option to disable add-ons without actually opening Internet Explorer. So if things break real bad, open up the add-ons dialog box that way. Now let's take a look at how to edit add-ons using group policy settings. This is what you would do in a slightly different scenario. If you fix the Yahoo toolbar on your boss's computer and your boss says, I want you to make it so the entire company can't install this annoying toolbar. Let's do that with group policy settings. Once again, I will go to the start screen and then run gpedit.msc. This is the local group policy editor, but you could do it using a domain group policy object just as easily. Now we're going to dig into the policy. As per usual, it's under Administrative Templates, Windows Components, and then Internet Explorer. As with the security settings, we're going to look under Internet Control Panel, and now we're going to go under the Advanced page. Here you will find a policy called Allow Third-Party Browser Extensions. By the way, you can click up here to have it sort alphabetically. If you know the name of it, that makes it a little easier to find. So I will open this policy, and if you click Enabled, basically it's the default configuration where Internet Explorer does allow third-party browser extensions. If you disable it, Internet Explorer no longer allows these add-ons. This might be a good idea, it might not. You'd better do some testing with the types of websites that your users visit, because there are add-ons that are legitimate and important, so it can be dangerous to prevent all third-party browser extensions from running just universally. I'll show you another related setting. I don't know why these aren't grouped together any better, but if you select Internet Explorer here, the root Internet Explorer node, you can find a policy called Do Not Allow Users to Enable or Disable Add-ons. This does exactly what it sounds like. If you don't want users to mess with the add-ons, if you want IT to be responsible for it, just enable this policy and then users won't be able to access that dialog box. That's about what you need to know for that part of this objective, so let's move on to the next demo. Now, before we start with the demonstration, I want to go over a term, and that's WebSockets. WebSockets are a standardized network protocol that allows web applications, usually it's a JavaScript code running within your browser, what's called a client-side JavaScript app. It allows those apps to communicate with web servers in real time. Now, to understand why that's important, you kind of have to understand how most web communications work. Web communications use a protocol called HTTP. That's the Hypertext Transport Protocol. HTTP is this really kind of archaic and slow protocol. It starts out with this three-way conversation. They have to say hello, and then the server says hi there, and then your client says, let's have a conversation. After this three-way communication, your client, the web browser, can then say, show me the default web page. And then the server says, here's the default web page. And then the client will say, show me picture 1, show me picture 2. And then the server sends all these back. Anyway, if you're getting bored hearing me talk about the process of displaying a web page, then you have some sense for just how laborious this HTTP protocol is. And it's one of the reasons that the web is kind of slow. Now, this means HTTP isn't great for real-time communications. When I say real-time communications, I mean things like games and chat, things where you want to be able to send and receive constantly. It wouldn't work well for like a Skype video chat, because you would say, the client would have to say, here's a picture of the guy that's talking and here's his first 3 words. And then the server would have to say, okay, I got those. You have some more words that you want to send? And it would never work for real-time communications. What you'd end up with is this choppy, jagged thing, probably with lots of buffering. So WebSockets are this network protocol that's supposed to fix this. It's supposed to allow web communications to happen in real time. So let's demonstrate how they work by opening up a website and monitoring the communications. So here we are at our Windows 8 PC, and I've installed a new app. It's called Microsoft Network Monitor. This is a free app, so just search for that phrase, Microsoft Network Monitor, and you'll be able to download it. What Network Monitor does is it records every bit of communications that go in and out of your network adapter. This is great for troubleshooting. If you're not sure why a particular network app isn't working, sometimes just by looking at the communications, you can figure out that it's, say, an authentication error. You might be able to look at the communications and see the server sending back an error message that the browser interface doesn't show you. And that's kind of what we're going to do here. We'll start by creating a new capture and clicking Start here to begin recording. Now you can see it's already recording some general network communications. We'll have to filter through this stuff. I haven't even opened a browser yet. This is all just background traffic that's constantly being recorded. So I'll open up a browser. Then I will visit a website that uses WebSockets. And the demonstration website that I'm going to use is www.websocket.org/echo.html. This is just a useful way to test WebSockets. So this web page is basically, it's a chat client. I'm going to chat with myself because I'm lonely. And you can see the first thing it does is it makes sure that the client supports WebSockets. So Internet Explorer 10 does support WebSockets. After this, we'll take a look at some other browsers that support WebSockets. So in a scenario, imagine that your IT department has set up a new website that allows users to chat with IT support, but it requires WebSockets. You're responsible for making sure that people can use it. Now, if you listen to what I just told you, Only Internet Explorer 10 supports WebSockets. Earlier versions of Internet Explorer do not. If you wanted to test it, you could open up the website, record it with Network Monitor, and begin to use the WebSocket app and then go and examine the communications. So you can see there's a checkbox here to use TLS, Secure WebSocket. That would encrypt it, which would make it more difficult for me to read in Network Monitor, so I'm not going to select that, but in the real world you probably would use TLS. So I will send myself a message, and that's enough for us to see what's going on. Now I'll jump back to Network Monitor and stop the capture. Now, as I said, this was capturing every bit of communication from all sorts of different apps. But I know that WebSockets uses the HTTP protocol. So to make it easier to find those web communications, I'll just put in an HTTP filter. And by doing this, it's going to show me only the HTTP communications. Now, the first relevant message to the WebSockets communications that we see here is a WebSocket protocol handshake. And you can see the status is switching protocols. If you look at this description, you can see that this particular message indicates that it's upgrading from regular HTTP to WebSocket communications. WebSockets still occur over HTTP, however. And so here we can see the message that came from websocket.org to my computer when it echoed the message back to me, hi from train signal. You can see it's buried within the HTTP protocol, and within that it has a value called HTTP payload line, hi from train signal. So that's how WebSockets work. Now, you might ask, the exam objective says configure WebSockets. How do I configure WebSockets? Well, honestly, you really don't. That's something that developers do within their app. As far as systems administrators go, there's nothing to configure. WebSockets work over HTTP, so the network protocol is going to be exactly the same for browsing the web, so you don't even have to configure a firewall or anything like that. I don't know why the exam tells you you need to know how to configure WebSockets. I want you to understand what WebSockets are, so when they come up in conversation, you know what they are, but as an administrator, you never have to configure them. That is the developer's job. So let's move on to the next demo. In this demonstration, we will show you how to configure Download Manager. So here's a scenario for you. There's a user in your organization who's constantly downloading new software updates. Imagine that they're new builds of Windows 8 or builds of Windows 8 Service Pack 1, and these files are like 2-3 gigabytes at a time, and maybe that user has a laptop computer with a 256 gigabyte SSD. That hard drive keeps getting filled up, so they want their new files downloaded to go to a much larger external drive. You could configure Download Manager to go to a different drive. So let's jump over to Windows 8 and see how you could do that. Now first you'll open up Download Manager, which is the same thing you do if you just wanted to see recently downloaded files. So from within the settings icon here, I will select View Downloads. And this opens up the View Downloads dialog box, which is Download Manager. If files had recently been downloaded since I last opened Internet Explorer, you'd see them listed here. Now to configure Internet Explorer Download Manager, just click the Options link here. Notice that there's not a lot of options to configure. You can unselect this if you don't want to be notified when downloads are complete. I don't know why you'd want that. And you can click the Browse button here to select a different drive. So we'll just select a different folder. And click OK. And that's all there is to configuring Download Manager. This is Tony Northrup for Train Signal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.